Welcome to this webinar that on energy storage applications for commercial and industrial applications in the Americas. I'm Dr. Peter Lilienthal. I'll be moderating. I'm going to wait one more minute as people are still joining, but we'll start very, very shortly. Well, I can see people are still joining, but I'm going to get started anyway. As I said, I'm Dr. Peter Lilienthal, the founder of Homer Energy and now the global microgrid lead for UL. The topic today is energy storage applications for C&I customers in the Americas. As you all probably know, in recent years, microgrid systems have emerged to supply sustainable energy. However, using an energy storage system allows several applications such as peak shaving, load shifting, or genset integration. Solar and storage microgrids have become a must-have to increase solar penetration and reduce fuel consumption. An energy management system such as the Illum controllers is essential to increase solar power plants' reliability and efficiency as it integrates and manages the different power sources. In this webinar, Sinexcel and Elum Energy will present the latest control solutions for solar panels combined with battery energy storage. Homer Energy, which is my company, we produce microgrid modeling software and provide analytic services to the renewable energy industry to optimize and simplify microgrids, and so I'll be contributing as well. Marty. He is now the sales manager for Latin America, US, and the Caribbean at Illum Energy. He's an expert on the microgrid market in the Americas and the Caribbean, and he'll share his knowledge on this domain during the webinar. Henry Chung is the managing director at Sinexcel Inc. And one of the founders of Sinexcel's energy storage and microgrid solutions. He's been deeply involved in the development of modular energy storage solutions driven by Excel, and now is in charge of global business development. He'll introduce the advantages of the solutions and services and typical cases for various applications in the commercial and industrial sector. I will begin and just present a little bit about Homer Energy and then introduce the speakers for the main part of the presentation. So a little background on Homer. It stands for Hybrid Optimization of Multiple Energy Resources. It's a technology and vendor agnostic platform to design just hybrid power systems of all kinds. It has a simulation, optimization, and sensitivity analysis, and it's become kind of a global standard. It was originally developed by myself back at the National Renewable Energy Lab back in the early 90s. It's been continuously updated ever since, but in 2009, we spun off as a private company, Homer Energy, created new versions in 2014, Homer Pro, in 2018, Homer Grid, and we're now about to release Homer Front for utility scale front of the meter projects. Back in December 2019, we were acquired by UL, which I'll describe a bit more in a second. Over these 20-some years, we've become a de facto global standard. Over 250,000 people have used Homer. The map shows where projects have been designed using our Homer software. That's over 4 million Homer files, over 90,000 projects since we started collecting that data in 2014. And we have about 120,000 people have opted in to our hybrid system design network and get our monthly newsletter. Now that we're part of UL, this is a global company. It was originally founded in the US in 1894, so been around for a long time. Where the UL is the preeminent standards and certification body for North America. But UL Renewables got going about 10 years ago as UL expanded its focus from safety to also include sustainability. We now have over 500 renewable energy experts and are very involved as independent engineers, owners engineers, due diligence activities on most of the wind and solar projects in North America, and we have offices around the world. It's not showing the Singapore and Dubai offices. We have over 100 offices, but those are the renewable ones, the ones that really focus on renewables. Just a quick list of some of our users. Actually, we have a huge number, but we like to show this slide. I'm going to move pretty quickly. This isn't really my presentation, but just a little bit about Homer. It at its core, it's a simulation tool that simulates the operation of a system hour by hour or minute by minute. It does that for many systems to identify the least cost system. It identifies what your fuel costs are, what your battery wear is going to be, what your replacement cost and operation and maintenance costs, finds the least cost solution. That's what's best for a particular scenario. But the built-in sensitivity analysis is really important to identify how robust those solutions are. And of course, it provides economic results such as your internal rate of return or return on investment. You can drill in and look at how systems operated hour by hour, and it will create a proposal that can be given to potential clients. We also do a lot of training, and now that we're part of UL, we have a very large advisory services group as well. Here's a list too big to go into of all the different kinds of advisory services that we can provide. And we have this newsletter, which might be of interest to all of you. So you can sign up for microgridnews.com, and we'd love to have you. With that, I'm going to hand this over to Marty to talk about Illum's controllers. So please take it away, Marty.
Okay, yeah, thanks, Peter. Thanks for the presentation, and kudos to you and the whole Homer team for the work you've been doing for the microgrid industry in the past years. So yeah, now let's focus that more on the Illum side. So on the control of the microgrids. Good morning, afternoon, and good evening to all the attendees that you are attending the webinar from all the different regions of the world. And basically my presentation will be structured the following way. So we'll start with a brief company presentation, and then we'll focus on the second chapter on the main topic of today's webinar, and finally just presenting briefly the products portfolio and some real references. So basically, Illum Energy, for those who are not familiar with us, we are a worldwide company with the headquarters in Paris, in France, and we have also offices in Casablanca and Cape Town. And we're happy to announce that despite the whole virus COVID situation, the pandemic year that we've been living, we can open new offices soon in Sao Paulo, Singapore, and Mumbai. So we're happy to keep growing and contributing to the sector. Basically, we have different kind of solutions for different kind of applications, but let's focus today on the microgrids with storage. Basically, our main three legs of effort in the company are the design, the commissioning, and the operational side. So basically, our solutions are built to give the maximum flexibility to the integrators. So we can say that we are compatible and we work to be compatible with all the new devices that are being launched in the market, such as PV inverters, battery PCS, genset controllers, sensors, weather stations, etc., etc. Regarding the commissioning of these kind of sites, we have three possibilities. So it can be done purely autonomous, or we can help full remote commissioning or non-site commissioning. So making this usually hard part of the system, making it as easier and straightforward as possible, and adapting the costs regarding on the size and budget of each project. And finally, since our control solutions are based on industrial computers, we can access remotely, we can update them. So with the same hardware that we've installed the first time, we can in the future upgrade the system by adding more solar, or for example, with the PV grid tied system, we could also add a battery in the future and completely change and customize a new EMS without changing the hardware piece. As I said, we are compatible with most of the main brands of the market, of course, with Sinexcel that Henry will present after me, and together we're building a really interesting solutions for the different markets. So yeah, let's focus on the topic that we are all here today. And before that, let's start with some fast definitions. So starting with the difference between a grid forming and a grid following unit. So basically, for any kind of system, we can only have one single grid forming unit at a time, and the rest of distributed energy resources will follow this grid. So they will follow the voltage and the frequency formed by this main grid forming unit. In here, when we are connected to a main national grid, we have to follow some grid codes, and it's important to follow this set of rules, and this set of rules usually are in terms of controlling the voltage and the frequency, or the active and the reactive power when injecting power into that grid to keep the stability of these systems. And basically, when we have more than one grid forming unit for a system, we need to separate both units, both sources, with an automated transfer switch to avoid the two grids connected to the same busbar at the same time. Okay, so which are the grid forming units, which are the grid following units in the systems that we are used to work with? So the grid tied inverters, they are always grid following. They will always follow a frequency and voltage formed by another unit. The main national grid, of course, it will always be a grid forming unit, mostly the biggest unit that we can grid forming unit that we can have. And then we have different sources that can be either grid following, either grid forming, depending on the site and the needs of each client. So in this case, for example, the battery PCS and the genset can act in grid following or grid forming, depending on the system. So what's a microgrid? A microgrid is basically an energy distribution network that relies on the distributed energy resources to make a system and produce electricity. This microgrid can be formed by PV, battery, genset, hydro, wind, etc., etc. But in this case, the main equipments used will be PV, battery, and we can have some gensets. And then we have two different kind of microgrids, or two principal kind of microgrids. The ones that we have with poor grids and systems that are purely off-grid. So let's start with the poor grid systems, which means that are grids that are extremely sensible to load imbalances, meaning that they have tendency to be congested and to collapse, meaning to have a blackout. So in here, what's the importance of having other sources that can provide us a safe supply of electricity, such as a battery or a genset with PV? It's really important, and also the controller that will make this system maximize the solar penetration, so maximize the benefits of our investment, and at the same time to make sure that the system is safe and reliable. So in this system where we have poor grids, that will be the main layout, and in here, in the terms of control, we'll have a cabinet that in case of Illum is called T-Power control, which will directly communicate with the different local control systems, such as the PV inverters, the genset controllers, the battery PCS, or some AC meters into the grid connection point. The communication will be done mainly in Modbus in order to constantly read and send registers, send commands to the different distributed energy resources to treat the system as a whole and to optimize the system, so maximize the benefits while keeping the safety of the supply. Then all this data is pushed to the monitoring platform for the later operation and maintenance, display of data, and export. And basically, in this kind of sites, we can ensure the zero export if the grid operator is not allowing a grid injection, or we can do other operating modes such as load shifting or peak shaving with the batteries that can be interesting to avoid some penalties or get some benefits by helping balancing the grid. And when the grid is down, and in this case we're acting with the genset as a main grid forming unit, the controller will ensure that the minimum genset loading, and at the same time we will ensure that solar is coupled with the grid formed by the genset in order to maximize the penetration. And these kind of solutions can be used for different cases, such as commercial and industrial facilities, hotels, resorts, and other real references that I will show you at the end of the presentation. So let's move on to the off-grid solutions. In this case, it's really important to have a battery or a diesel genset to form the grid. So in this case, we'll have two possibilities: either the genset is forming the grid and the battery is used to increase the self-consumption and to optimize the spinning reserve, or the battery is forming the grid and we can work completely with the gensets off. And same as before, it's really important to have an optimal control and monitoring of this kind of solutions to maximize your benefits and reduce as much as possible the fuel dependency in terms of cost and carbon footprint. So the system will work the same way as before. We will integrate with Modbus communications with the different devices and design a custom control for each system to maximize the benefits and ensure the reliability of the whole microgrid. And then, aside from ensuring the minimum genset loading or making it possible to use the solar when we have the gensets forming this grid, we can also optimize the spinning reserve through the gensets or the batteries to increase the benefits of the system. And in case we're using the batteries as the main grid forming unit, as I said, we can work with the diesel off mode. You will see there's a lot of letter, but I will send you this presentation so you will have time to read carefully all the information. And if you have any question, you can ask it at the end of the presentation or after the webinar. Other potential study cases for this kind of solutions, such as for rural electrification, small and medium mining, or the agriculture, fishery, and the forestry, which is really common, I would say mainly in Latin America, systems that you can find which are based only on diesel or gas gensets, which can be easily upgraded with solar and battery to make the system more reliable and with bigger benefits on the client side. So as a sum up of all the systems that I've been explaining in the previous slides, we can differentiate between the grid tied and the off-grid system. So in terms of grid tied, we can have grid tied purely PV battery systems, which can help us for self-consumption, but also for helping balancing the grid and get benefit from it. Other systems which we can have also a genset as a backup. So in this case, we can work in grid tied modes with the PV and the battery in grid following, but whenever the grid is down, the genset will kick in as the main grid forming unit, and the controller will ensure that PV and battery are being used and maximized as well in this backup situation. In terms of off-grid examples, we can have two solutions, as I've been saying before. So either using the genset as a grid forming unit or using the battery as a grid forming unit. Using the genset as a grid forming unit would be maybe a lower investment because you can size a smaller battery that can help you increase your benefits of the system. But if we can make a bigger investment in which the battery can be capable to supply all the loads, then we can use this battery as a grid forming unit, keep the gensets off. And for example, when the state of charge of this battery is below 20%, we can send a signal to the gensets to turn on, couple the gensets to the grid formed by the battery, and helping charging the battery and supplying the loads. So this way, whenever the state of charge reaches again an 80%, for example, we can turn off the genset again, and we can have a really interesting scenario. So I'm going to move really fast on the products portfolio because I see that I'm running a bit out of time, and I would like you to have time to ask questions at the end of the session. So basically, we have a different kind of products depending on the size and the complexity, from purely standard solutions to purely customized solutions. So in case of PV, in case of microgrids with batteries less than up to 1 megawatt, we can use the e-power control MC. If we are talking about sites without a battery up to 1 megawatt, we can use the e-power control HFS. And then if we are talking about sites bigger than 1 megawatt with bigger complexity, bigger size, then we can use the e-power control PPC, which is a fully customized solution to maximize the benefits of each sites. And then we provide our own SCADA, and I will just pass really fast on these slides for you to see the configuration platform from a side, where you can see the production of each source, the status, etc. And then we move on to the monitoring platform, which can help you not only do the display of the data, but also to have all the historical data, to have to be able to export the data, and to have some alarms for your site. So this will allow you to have all your sites in the same platform, no matter the equipment you're using. If you're using different kind of PV inverters for each site, for example, you can rely always on the same monitoring platform to have a better access and easier access when doing the operation and maintenance. And same as before, I will just pass past these slides, and you will have time to see it when we send you the slides after the webinar. And just to conclude my part of the presentation, let's focus on some real references that in the end that's what matters. And starting with a resort, as we were saying before, in this case in the Bahamas, a small resort where the genset is forming the grid, and we have an e-power control MC. But then we have other off-grid sites, for example, like in Puerto Rico, which we have the off-grid hacienda, that is where the battery is the one forming the main grid, and the genset is only being turned on whenever the state of charge is lower than 20%. And we have, for example, this Aquina. This is a pharmacy that we have a 1 megawatt genset plus storage, but in this case, as we see, the genset is bigger than the storage. So first we use the grid, then we will use the gensets, and as an ultimate backup, we can use the BESS to form the grid and supply some critical loads. And to finish with a really interesting project we've finished not so long time ago in the island of Comoros, of 3 megawatt solar with 2 megawatt of storage and 6 gensets. So I think it's two main grids formed by genset, in which the e-power control PPC needs to manage the storage, the BESS synchronization, and do the transition between all the modes. So maximizing the benefits and keeping the system in a safe environment, and the grid perfectly balanced. And yeah, we will end up here. It's already time. So just don't hesitate to ask more questions on the chat box that we will answer at the end of the webinar. And after the webinar, don't hesitate to contact me or contact the Illum team. And that's it on my end. I will pass the microphone to Henry to continue with this presentation more from the battery side.
Thank you. Hello, this is Henry. Can you see my screen? Okay, good. So let me start. All right, so thank you so much, Marty. I think that you have got a very good presentation about the applications. Right, so thank you so much for your time, everyone, to attend to this webinar. Right, so it's my pleasure to present something about ours. I will start with who is Sinexcel, and then coming with the Sinexcel products and the services. Finally, the last part will be the showcases, right? The typical cases for different applications, right? So feel free to ask any questions, and you could also send me email after the webinar, right? Or contact me or visit our website for more information. Okay, so now you see the first slide is about the company, right? So Sinexcel is focused on the service and the product, right? So you can see how the name came from. And I'm from Sinexcel Inc. And this slide is just we are focusing on the commercial and industrial level and storage and microgrid solutions, right? So we are presenting or promoting ours as the solution driven by Sinexcel. So you can know more about ours in the coming slides. Right. So actually we start the energy storage business since year 2011. So there's almost 10 years since now, and we have got 800 plus projects and 800 megawatt PCS, and also serviced 500 megawatt hour ESS globally. And this slide is showing that where we are. Right? So our factory is located in China, and the engineering center is also here. Right? And the Sinexcel Inc. is a subsidiary of Sinexcel in US. So we are based in California. We are providing the local service and the support at Pan America. Right? And we also have another subsidiary in Australia, Brisbane. So that is a focus on Oceania. And we are also having our partners in North Island now, which is providing the local service and pre-support. And we are planning to set up our own facility in Germany to cover the Europe and Africa shortly. So in the main sectors of our applications, actually, you can see on the slide, we do have 6 different areas, right, including commercial and industrial. We also are looking at the community power supply, the rural area, and we also have a few applications on the T&D and the power generation side. So the main difference makes us different from other people is that we're providing the modular energy storage and the microgrid solutions. So that is the biggest advantage and the features of our solutions, right? So our product have 3 main sectors, right? The first one is the power conversion system, including the PCS, inverters, right? And the second one is a pre-engineered system. Actually, we are not providing battery and EMS. So for battery technology, you know, there are a lot of different technology, including Samsung, LG, and CATL, all this brand name. So we are cooperating with them. And the EMS mainly come from partners like Illum Energy, right? So we can benefit from their expertise. And also Homer will get involved with the analysis and sizing. Right? So that is how we cooperate with our partners. And beside that, we're also providing the integration service, right, by using the batteries in China and control software remotely, right, to get everything tested and pre-engineered, right. So make sure that there's no extra works or can save time on the field commissioning. So next slide is our main advantages. So you can see from the screen that we are the reliability, right, flexibility, and the compatibility is the main features. I mean the feature our solution providing, right, including the products, right, the certifications, right, and also the experience. Right, and we have our modular design, which is very good for the flexible applications, right, especially for CNI. I think that most people understand that the demand and also applications varies quite a lot. Right, so with our special design, we are defining our products to meet this special requirement, and also compatibility, right, including different AC voltage, different batteries, and a different grid code. Right? I think that you just know from Marty's presentation, right? The grid code is very important for the grid connection applications. Right, so our following is just our mission, right? So our mission is to maintain the use of energy, right? Simple, flexible, and stable. Right? That's the very important purpose or target of our solutions. And following will be our vision. So we believe that the freedom of the use of energy is very important to everyone. So the energy freedom driven by Xenxel is very important, and is our vision. We would like to work for that, devote ourselves into this target. And the following is our core value. So we are helping our partners to be succeed. So that is very important for us. And we are always presenting the innovative solutions to help our partners and help our customers to solve their problems, right? And also Xenxel and Xenxel is the company names come from. So the next slide is just showing that who are our partners, right? Because as I mentioned, we do not providing the whole system to the end user, but we provide the solutions to our partners. So you can see that we are partnering with a battery supplier, system integrator, and also the EMS provider like Illum, and also engineering service provider, right? So our engineering service provider providing the local support and installation and commission, right? So we're providing the turnkey system integrated and tested in China in factory, and then they will help the customers to do the local service. Okay. So the following will be the main products, right? So we start with the power conversion products, right? So on this slide, you can see that the whole product family, right? You can see that our product covered from the 30 kilowatt to 500 kilowatt per unit, and we have different applications, different market, different certification, right? So our product are mostly indoor used, but we do have outdoor enclosure to make it compatible with different environment, right? And the battery voltage is quite flexible. You can also see that we are using the same cabinet that equipped with different power module to get different power of the rating, right? So if you need more information, you can visit our website to get more information or send an email to me. So the features of our PCS is that we have got certification, right, and a listing on the national recognized testing labs, right, like including ETL, Intertech, and TUV, right. Our product has been also listed in the authorities of every country, right, mostly like in California, in Hawaii, right, and also in Asia and Europe and Australia. Right. So the other advantage of our products is that we are certified products, and we do have the certified products in the lab, right? So you can see from the screen like that from Europe, US, Canada, Australia, Austria, right? And also the different cities, different countries. And the other one is that our product and solutions are covered by the product liability insurance. So that will make the people, right, or the user and the EPC less concerned about that. Okay. So the next one is that multi-string, some technologies, right, and design of our products, right. So on the screen you can see that we do have the multiple string technology. So this technology is based on the modular design. So we can equip with the different string of battery together with each power module and to get it working. And we can even connect different battery technology into each different string, right? So that makes the application much easier, and also the modular design and could enable very easy expansion. Because we do have some project had benefited from this design. So later on, you can know this from the typical cases we do have. And on the right side, you can see that our overall module is front maintained. So it can save quite a lot of space in the integration and the service. Right? So that is very good features and have been welcomed by quite a lot of users. So the next slide, I'm just showing all of our products has grid forming and grid interactive functions built in, right? So you may also notice from Marty's presentation that grid forming and grid following is different, right? But all of our old products, our PCS could working in both modes, and some of the technology had been implemented now like that. Multiple units could work in parallel to get a grid forming capability. So if you have more interest, you can contact me about that. So following will be the next part of our product, the pre-engineered system without battery and the EMS. So you can see from the screen, right, the blue part is what we are providing, including the PCS, the container or cabinet system, the local controller for the safety and maintenance, and also the system integration service. But other than this, like that cloud-based EMS, like the strategy definition, right? The working algorithm definition is provided by the partners of EMS like Illum, and also the battery coming from the different battery companies. So actually, right now we already cooperated with many different batteries supplier, including lead acid battery, lithium-ion battery, LFP, and also the flywheels. Right? So we do have quite a lot of different partners globally working with different applications. Okay, so for our system, we do have the features like showed on this slide, right? So we designed the product from the purpose of the plug and play. We get everything, almost quite a lot of things pre-assembled and pre-tested to make sure the quality is good, and also it's very easy to be expanded and very easy to be serviced. So next slide is showing that what we have on the container on the pre-engineered system side. So you can see that we do have the AC coupled system and the DC coupled system, right? So we do have the all-in-one solutions and battery only solutions. So you can also notice that from the power range, it covers from 30 kilowatt to 1 to 2 megawatt. And on the energy side, it covers from 100 kilowatt to 4 megawatt hour. Right. So this size offers quite a lot of flexibility and quite a wide range covered the main applications in CI sectors. Right? So as mentioned, anything you're interested, let me know by email. Okay, so following, I will just give you a brief introduction about AC coupled solutions. Right. So we do have the 4 products. Right. So you can see that on the single line diagram. Right, we do have our PWS series PCS and coupled with diesel generator, right, providing, and also PV farm, right, providing the power to the load, and also connected to the grid, right. And our PWG series product could also be paralleled. So although the PWG itself is a DC coupled system, right. So just like that, the next slide showing, right? So you can see that quite a little bit more detail about the DC coupled system, right? So we do have our own power module inside of the cabinet, and then the PV panel is connected directly into the DC bus bar, right? So our PWG series product could offer double size of the PV input, right? So it means that it could maximize the PV generation and also maintain the stability of the system, right? And we do have the option for the built-in smart transfer switch. So this transfer switch will offer the automatically transfer between the off-grid and on-grid. So it will censor the grid status and to instruct the PCS to switch over automatically. Beside the PWG series, we do have our DC-DC coupled DC-DC system, which can connect the PV into the battery, charge the battery directly, and at the same time, the PCS will connect with grid or load to offer the grid forming or load support. Right. Okay, so it's a little bit slow. I will move faster. Okay, so this is an introduction about the container system, right? So we do have the 10-foot to 40-foot, right? So different energy density from 1 megawatt to 4 megawatt hour, right? And also the next slide is showing the special design we do have for the CNI acceptor. So this sector is for the 30 kilowatt, 100 kilowatt hour cabinet, right? We do have indoor solutions, right? So there is also optional firefighting, right, control software, right, working with Illum and other controller. So the next one is showing the grid transfer switch, as I had introduced, right, like that to automatically detect the sensor, the grid status, and also local controller for the local maintenance, right, service. Right, so in the system integration service, we are providing the BMS and the EMS integration. Right, we are also helping to improve the thermal performance and to running the battery test cycle test. Right. So following will be the main records we do have globally. So you can see that our sites covered almost every continent, right? So 30 more countries, and we do have a different category for the applications. So you can see that we have defined them into 7 different categories, like the demand charge management, frequency regulation, peak shaving, spot market, energy buffer, microgrid, and backup power. Right. So in the following slides, I will give you some introduction about these typical cases for each application. Okay. So for the frequency regulation, so I think that almost people understand that how it works, right? So I just give you some information about the cases we do have. Looks like that the internet has a little bit slow. Okay, come up. So this is the biggest project we had. So we have got 72 megawatt hour system. So this system installed into 2 sites. So each site has 36 megawatt hour. So technically speaking, I think that this is a commercial application, because although it's connected to the grid, that it is running by a local local energy company. So they use this to benefit from this frequency regulation service, right? So you can see that it's already running for 18 months, right? So right now the performance is quite good. Okay. And then the next one is demand charge management. Actually, I think that in North America, especially in America and South America, there are a lot of applications benefited from this cases from this application, because demand charge is quite high. So we have installed that into one cinema. So this is the AC couple system, and actually the whole container is okay. It's coming out. So this is a cinema application. So it's a start with a 20-foot container, and we do have installed only 375 kilowatt and 750 kilowatt hour in the beginning. But after that, the customer found that is very helpful. So they are expanding the demand. So finally, it is 500 kilowatts, 1 megawatt hour, and to benefited from the modular design. So it is the expansion is quite easy, because no AC wire is required. Right, so there's you can see that this is already 3 years ago. So until now, the performance is quite good. And beside that, we are also install the small systems, right? So the one shown on the screen is in South America, right? So this is the outdoor cabinet, and is installed in the gas station to cut the peak shaving, demand charge, right? So that is a very good application, right? Modular design compatible with different system, right? So this is also helped quite a lot for the customer's electric bill. And then the following is the one in California. So this is an indoor application. We do have installed several different sites similar like this, right? So you can see that this they also cut the bill for the warehouse. Okay. Right. The following will be the load shifting. Okay. So this is in Netherlands. Actually, so it's a little bit too slow. So you can see that there are a lot of electric forklift, right? So based on the energy storage system, So they have benefited quite a lot of the demand charge. And also the following one will be the one in New Zealand. Okay. Sorry about that. So the next slide is the sector of the spot market. Actually, in North America, the electricity deal is quite good way of the revenue generation, right? So on this one, we are incorporated quite the 4 containers for 500 kilowatt, 1 megawatt hour each, right? Connected with a PV farm. So this PV farm is generating power, but it is stored into the ESS and to benefit from the sales of the electricity, right? So the next sector is energy buffer, right? So you also notice that the EV is growing, right? So it's growing very fast. So we can connect the ESS together with the EV charger to reduce the impact of the electricity and the grid, and make sure that it offers quite a lot of benefit and enable the expansion of the EV market. So their following is off-grid power supply. Okay. So this is the one we have installed in California, Northern California. So this is working with lead acid battery and indoor applications, right? So this is for the camping pace, right? Mostly for the off-grid. And the next one is South Australia. Okay, so South Australia one is used to pump the petrol pump, right? You know that the punch pump always have the inrush current, right? By using the ESS, could save quite a lot of diesel consumption, right? Diesel consumption. So that is also very good for the microgrid, and also powers the electricity nearby. And the last part is the backup power. Okay, so the backup power, the cases I'm showing is the one we installed in Anguilla, right, in the beautiful island, right? So you can see that it's installed only 4 modules to get 250 kilowatt, right? And the main application is just to power the supply during the night, because the diesel generator, diesel genset is always deliver the noises and the smelly, right? So that is not good for the people, for the hotel guest, right? So that this is the AC coupled system, and we could also expand that very easily by put more power modules into the system. Okay. All right, so that's all for my presentation, right? And the last slide, you can see my email and a phone number. So feel free to let me know if you have any questions. Right, so I think that it's a little bit out of time. Sorry about that. Peter?
Yeah, thank you, Henry and Marty. And we've got a lot of questions here. We're not going to be able to answer all of them in a couple of minutes, but there's several of the questions are kind of similar on the question of transferring between modes, between when the diesel is the grid forming versus when the battery is the grid forming versus when the main grid is the grid forming, when the battery is charging versus discharging. Could you all address how seamless that is? How does that happen when you switch between one mode to another mode? How seamless is that? And
Okay.
probably for either of you. Yeah, go ahead. Sorry.
Yeah, I can start, and then Harry, you can complete my answer. So yeah, basically there will be sites. Most of the sites, I would say that there's not a requirement to change the mode from grid forming to grid following. But if that's the case for some sites, that should be done by sending a command, so by changing a register directly from the battery PCS or the genset controller. So the velocity of doing this, executing this transition from one mode to the other, it depends on each device basically. And in case of the batteries, I know it's much faster than if we're talking about gensets, of course, since the startup is way faster. And then we need to be sure that, for example, in this case, talking about the PCS, that this PCS has the capability to black start, so has the capability to change this mode. And I guess that's perfect for Henry to complete this in terms of the Sinexcel PCS.
Yeah. Yeah, thank you very much, Marty. Yes, that's right. I think that you got almost a point. Actually, I think that Peter had asked two questions, right? The first one, that how fast from charging to discharging. Well, Sinexcel, our product, could offer the 100% power from charging to discharging within 50 milliseconds. So that will cover the most of the applications, especially this is the reason why our equipment could be used for the frequency regulation. Right. For the second part, especially Marty mentioned about that the grid forming to grid following. Right. So I know that there are quite a lot of customers who would like to know if the ESS could replace the UPS. But frankly speaking, I think that is a little quite a lot challenging, right? But we do have the solution, right? That is the smart transfer switch, what I mentioned, right? So with that equipment, we can get it done within 200 milliseconds, right? Like that, almost within several cycles to get it back to power supply. So I would say that it can cover most of UPS time. So it can perfect good for the UPS extension, right? So that's all my yeah, that's all.
There, there are also some questions about size limitations. And so again, I'm going to ask two questions at once. One of them is about the minimum battery size for grid forming capability, and another one on whether there's any size limitations for the PV that's connected to the system.
Okay, so maybe I can also start if you want, Henry, and then you finish.
Sure.
Okay, so basically in terms of battery to be able to be grid forming, or at least to be able to be grid forming in a safe environment, that I guess that's what we all want, is that one, it needs the BSS, we need to make sure that we have the capability to be grid forming, that's for sure. And second is that the capacity of this battery is higher than the maximum loads, meaning that no matter the loads we are having, that this battery will be able to supply the loads. So the problem will be that the loads are higher than the battery, so then we will create an instability, and that's not a good solution. And regarding the PV sizing, that's more on sizing it to avoid having a lot of PV curtailment. So rather than stability, so in a way, if we oversize the PV system with respect to the battery or the gensets, if there are, we will be not using most of the production, and economically that will not be good. And in terms of stability, there's a lot of debate, but in our case, we always say that in terms of installed capacity, it would be maybe 60% and 40%, so 60% solar, 40% the grid forming unit. But I guess that's a big debate that we can be discussing for hours.
Yeah, Marty, I think that Marty got a quite good point, right? But from my point of view, I will say that based on this close to 1,000 projects we had experienced, we believe that the sizing is very important, and it's more related with applications, right? So for example, like that the UPS or backup, right? Maybe if you want to just extend one hour, right? Then that will be 1 hour rating. It should be good, right? And it also related with the battery you chosen. You know, some different batteries, they are supporting different C rate. So technically speaking, C rate is a technical word, right? So if we change it that to normal phases, it will be like that. How long you want the ESS lasting, right? The battery storage system lasting, right? So like that 1 hour, and then it's 1C, right? And 4 hours, then it's a quarter C, right? 0.25 C, right? So I think that this is quite related with that. For the PV side, I believe it's also related with the grid height or off grid, right? So Marty got a very good point, right? So if there is a zero export, then the higher PV or large PV cannot support, cannot generate too much economic value, right? For the off grid application in DC coupled system, I will say that there are very limited, very limited restriction, because in the DC coupled system, it's more related with the PCS power. But for the AC coupled system, I believe it is recommended PV power not to exceed the PCS or the storage power. Otherwise, the whole microgrid might face the challenge of the stability. Right. So, but as I mentioned, it varies. You know, for the CI sectors, too many different applications. So I think that is very good for Homer to present the analysis tools, right? Is that right, Peter?
Yes, there were a couple of questions that are right up our alley in terms of, you know, what's the economically optimum sizing? Some of these things are economic questions about sizing of the different components. So there's a technical issue, you can't exceed the capacity of the equipment, but then there's an economic issue about what's really the economic optimum for sizing the PV and the batteries. And it's really very local, very site specific, depending on load shape and local costs of equipment. So that's the main function of our Homer software, and we'd love to follow up with you on that. So we've reached the top of the hour. I believe we're going to try to answer there's I don't know, dozens and dozens of questions. So I'm sorry if we didn't get to your question in this hour, but we will try to respond by email to you. So I want to thank you all for joining the webinar, and I hope it was informative. And I want to thank the panelists. They gave great presentations. And unless Illum or Amanda or Marty or Henry have a concluding comment, I will sign off now.
Thank you so much, Peter.
Yeah, same here. Thank you, Peter. Thank you, Henry, and thanks to all the attendees for being here this hour.
Right. Feel free to let us know any questions you do have. Right.
Okay. Well, thank you again, and goodbye now, everyone, and have a good rest of your day.
Yeah. Have a good day.
Okay,
Bye-bye.